someone says something, the first question is kind of scoping out what you want to know. So I have one of the football players is doing a capstone with me, and he said, I want to do something with concussion. That's not a research question. We need a research question, like what is it we want to know? So we got data today from the sensors that are in the helmets, so we're looking at specific things. We scoped out the research question today. So, and he's doing some data exploration, but really it's, can I use this sensor data to predict whether someone has a concussion or not? So now he has a scoped out research question. And unbelievably, when you have real questions, this becomes really hard. So the dietitian that's on post told me that she feels that athletes are not getting enough to eat. That's not a research question, right? So she sat down with us, and when she sat down with us, let's see, we sat down and said, okay, what is the research question you would like us to work on? And the question is, are core squad athletes getting enough to eat? So if you're on a core squad table, how many of you here are on a core squad table? You get extra food, right? And she believes that people aren't eating the extra food because they don't like it. So step one is to ask that research question. How can we answer that question? What tools and what data do we need to know? Data are the values that are measured, or the categories that are measured. It could be a category, right? Are they getting enough or not getting enough? That's a category. Bin 1, bin 2. So those are the two things that you kind of have to scope out this question. And as we're scoping it, we start moving to step 2. So it was Colonel Clark and I. Colonel Clark is teaching another section of 206. And we were asking questions, and we said, okay, we think you need to measure how much energy they need to consume. This means we need their goal weight. What goal weight do you want them to be at? And we need an estimate of how much it takes to maintain that goal weight. Or it might be muscle, like we don't know. So that question was, when we sat down with her, that was just like a half an hour of messiness, just asking this question. How much are they consuming now? How do we know how much you're eating now? That's actually a super hard question, because memories are bad, and you might not want to tell someone you had that ho-ho. So you might want to mask some things that you're eating. You don't want to tell people, or you just forgot. I think of one of the biggest reasons we just forgot. So we need measurements of how much they're eating now. So we spent some time talking about this. I have a data set with college athletes from Portugal where they have these measurements. You can actually measure this. It costs a lot of money. There's something called doubly labeled water that people can ingest, and it's like a chemical isotope that you can actually detect how much energy the person's expending from that, and from that you can estimate how much they're eating. But you also need body composition, and I like clean data, so I need it with something called DEXA, which is expensive. So we were talking a little bit about how we're going to collect these measurements. You can't ask people. Actually, I published too many papers on you can't ask people, because I show with mathematics that it's implausible. People will say they're eating 500 calories. Some people will say they're eating 10,000, like Michael Phelps. I did the estimate myself. He's not eating 10,000. The next step is to design the study and collect the data. So, Colonel Clark and I were talking about how to design that study. How much energy, we need to know that these things, right? So how are we going to design that study so that we can learn those things? Well, we have data in Portuguese college athletes that already have these expensive measurements. So maybe they don't have football though. And so we talked to them about, do you guys have rugby? So I'm going to come back to them and ask them, do you have rugby? Because that might be close. I don't think they have rugby. They haven't given me rugby in that data set they gave me. So what do we need to measure here? Doubly labeled water costs a lot. Is there some existing data from NF? We're designing the study when we're asking these questions, right? We're thinking about how do we answer that first one? How do we get that measurement? Without directly going and measuring every single cadet athlete here. That's going to cost a lot. It's also going to be a big burden because you have to pee into a cup a couple times in a week, and it's like a pain. That one, how do we get that? Well, I told you, I published papers on not using self-report. So they talked about using self-report. I don't want to use self-report. That's bogus data. So I talked about taking pictures of their food while they're at the mess hall, looking at maybe who's delivering the food at night, so we can get a handle on how much calories are coming in. So I'm looking for objective methods, not subjective methods. I always go back to doubly labeled water. See, there's no way you can know how much someone's really eating unless you collect this. Okay, so next step is to explore the data. Once you have it all in an Excel file, then you explore the data. We're going to be doing a lot of that this semester. I'm going to a different topic just to show you an example, a quick example. Who's my swimmer? Someone's a swimmer here. It's Cadet Jenna Forrester from last year. That was her capstone. She looked at accelerometer data, steps, and I think this is total time spent in intensity. So each one of these bins, these are the most slow people, they barely move, and these are the most intense people. And she put this is called a box plot, so you'll be doing that this semester. And so what it does is it tells you, and these are depression scores on this axis, and it tells you that people who are pretty sedentary look like they have higher depression scores, right? That makes sense. Doesn't it make sense? But then you see this high median over here. And so there's actually a poster down by my office where someone published in Lancet, which is one of the top journals in medicine, that if you work out too hard, you can get depressed. That was the conclusion they're making. And that made me like, well, people work out pretty hard here. And I don't see everybody walking around. Well, cadets laughed at me. I had a convocation when I said, do whatever you want here. But, I don't see actually officers walking around looking depressed. And so they work out pretty hard and they're not depressed. And so I said, I doubt that. And then Major Adams, who's also teaching a section of this course, looked at that and said, they smoothed out this curve. The issue here with this data, as we're exploring it, there aren't too many people in the United States that are this intense. And so there's less data in this bin. You don't see dots here. So if one person was depressed and one person's not depressed, what's going to happen when you average them? Right, you get bogus results because the sample's too small up here. So we think that the results are spurious that they're finding with people working out very hard and being depressed. We don't think this is real. So Jenna kept up the data analysis to kind of tease that out. Go ahead.
Why don't they touch that in peer review?
That's what I say. So a letter to the editor went up after we saw it here. They said you can't do the smoothing curve thing. And so people will respond with a letter to the editor. I believe no one would let me get away with that, but yeah, you shouldn't be publishing something that has that issue.
Should the correlation be the other way, that they work out because they're depressed instead of like they're depressed because they work out?
So that's really important. It's one of the last things in that process. It's called causation, right? So this is people from the United States who wore one of these things. This is my Garmin. And they collected data from those people, and then we're binning all those people. That's called cross-sectional data. And this is an observational study. It doesn't mean that people who don't work out hard will become depressed. That's causation, right? So I can't make that inference from this data, from this study. How would I do that study? How would I find out if I took people who are depressed and they worked out hard, would they get less depressed? What would I have to do?
Well, you need to have like a control group of people who are depressed and maybe don't work out much at all, or they maintain their current level of physical activity, and then you take another random sampling of people with depression, and then you have them work out like an elevated number of hours and see if over time there's
That's right. There's hardly any studies like that. And you can imagine why. If this is a cross-section of the United States, there are no people here. We're homo sedentarius as a nation. And so to run that study, you need people who will be willing to work out hard, who are depressed. That's a hard study to do. Okay, then you want to draw inferences from beyond the data. In Jenna's work, we found out we cannot infer that people who work out hard have higher depression. We're unable to do that. So we were very cautious in saying we can't do that. There were too few individuals, so we can't make that inference. But she used something called logistic regression, which you won't learn in this class, but if you love this stuff, you can take 376. That's the class you learn that. And she found out that increasing your intensity does decrease your depression in this data set. It's cross-sectional. So that was her conclusion. That's the inference you make from that data. And use statistical methods to get to that point. And then she says, we conclude that individuals with higher activity intensities are associated with lower depression scores. That's not, when I say associated, that's not causal. It didn't say caused lower depression scores. You have to be very careful in saying that. We have a paper that just came out today on childhood obesity and the things people say that make you believe certain things. You're overextending past what your data is saying. And so we always reserve our conclusion. We have reserved conclusions because high intensity bin has low sample size. And then you look back and look ahead. Like you said, the randomized control trial. RCT stands for randomized control trial. It's the biggest method we have in data for proof. It's not a mathematical proof, but it's as close as we can get to one. And that's where we have two groups. One get the intervention, one don't, and then we see if there's a difference. We also suggested they do the study here, because then you have a sample of high workouts, high-level workouts. Do it during CFT, right? Take the people with the Recondo badge. All right, so for next class, what I'd like you to do is on page 13 to 14, there's a glossary of definitions. And I'm sorry to do this to you, but I just want you to memorize them so that you have that done cold. You should be good at that. It's annoying to memorize definitions. Major Adams warned me that you guys will have issues with observational unit versus variable. Variable is something you measure. An observational unit is the row in the Excel file. So if it was, in this case, the row would be an individual, right? Individual with all these depression scores. The things we measure is their depression or their steps. Those are the variables. So the columns are the variables, the rows are observational units. There's a homework. I suggest you do it. It will take 5 minutes to do. 5 minutes. You did it already, right? The homework?
Like P.2 or P1.4.
Yeah, it's easy, right?
It was pretty easy. I don't
Yeah.
think it's right.
I can't find the readings of the problems. I thought it was in this book, but it wasn't.
Yes, ma'am. I think some of us were issued different textbooks because I have a code for WebAssign, not Web.
That's the regular 206. We're 206Y, which is better. So it's a different book. It's a Wiley Plus book. She's got it. Can you hold up your book?
I took a picture of it.
Yeah, take a picture of the cover if you need to.
Oh, man.